So our third example in Chapter 15 takes us kind of back to where we started. We're going back to mailing lists, and we're going to actually crawl a web-based archive. And this is a site called Gmane.org, and it archives mailing lists so that if a project kind of ends, you can have an archive for a long period of time. And so we're going to crawl it using standard crawling, and then we're going to do some analysis and cleanup because the mail is a little bit tricky because the mail lasts over almost a 10-year period. And then we're going to do some visualization of the data. And so this is also the largest data set that we're going to play with, although the web is gigantic. You can do the first two things like the geography one with like 20 records, and you can do like 40 or 50 web pages. But if you pull this whole data set size down, it's greater than a gigabyte. And so if you just set this thing going all night, especially if you use Gmane.org, this is not a rate-limited API, but if you read their websites, they tell you, please don't hurt us. We don't want to write the software to do rate limiting, and so as long as we're all friendly. So I will give you a special URL in the assignment that will be a non-rate limited copy of this. So I'll put something up at one of our university servers that will be a copy of all this stuff that won't be rate limited. So please use the non-rate limited copy, although you can do playing on your own with talking to the data directly. But please use the non-rate limited copy if possible. So here we go. This is the most complex thing that we're going to do. We are starting with a gathering phase. Gmane.org has all these mailing, and we're going to do a lot of work on this stuff. And so the first thing we're going to do is make a local copy. And this is the standard thing where we're going to retrieve it, hit the URL, parse it, and stick it in a database. So this is going to be a relatively simple looping activity where, we'll have some data in here, we'll figure out what the next one is, and we'll go loop and read and add a few things. And if we get blown up, that's okay because we're not going to go backwards. So this is our nice local copy. This is a very raw copy of all of our data. Now this data is a little messier than the data we've been working with before because it's email that lives over a 10-year period. And it's a lot of data. And just running something across this is greater than a gigabyte. Okay? It's not compressed, we've not parsed it, and if we really were going to do analysis off of it, depending on the speed of your computer, it might take minutes or hours even just to read through this data and do all the parsing. So what we're going to do is we're going to make a second database, and we're going to have this database with multiple tables. We're going to do third normal form. Remember that from previous lecture. Third normal form is going to be all these integer keys. Remember that, right? So this is going to be a wisely built database, which means it's going to be much smaller because of the lack of redundancy. And when you run gmodel.py, which copies from this database, just note in your mind how long it takes to run gmodel.py versus reading this after we've cleaned up the data. And that's why we do this cleaning up step. We tend not to do the cleaning up step when we're doing this because we want this to be simple and focused on restartability and reliability and simplicity, because we might learn something about the data, and we keep the raw data and we reparse it every time. So you probably end up changing this code a lot more often when you realize, oh wait, there's another mistake in the data, and I got to rerun the thing that goes from the raw data to the clean data. So this is the clean data. So this is much smaller, it's normalized, it's cleaned up, it's a very well organized database, and the data is much smaller afterwards. So now we have all of this data in a very clean little database with a bunch of little tables in it in content.sqlite. And we can run a number of applications on this, okay? And so this is the actual analysis. This is the clean phase, this is the gather phase, this is the analysis. We're just showing how you can have this pipeline of data coming in and then do a bunch of different analysis once you've got nice clean data. And so this is going to be a loop that just sends an SQL command to read through all of this data, and then it's going to do something like make a dictionary and compute who the top 5 people are that are sending email on this mailing list, or the top 5 organizations. This is going to look a lot like the programs that you've written before. Read, split, dictionary, get, all that kind of stuff that you've done before. Okay? And it's just dumping them out. So it's very similar, other than the fact that its source of data is data we've gathered and cleaned up. Then we have another thing that makes a word map, and it's sort of taking something similar to this, but instead of looking for the from address, It actually takes the body and breaks it into words, splits it into words, throws things away, and then does a frequency analysis of the words and prints that out in JSON format. So when this program gword.py runs, it produces gword.js, and you can take a look at it, and you'll see some curly braces and colons and single quotes and stuff like that. And it really is a mapping between each word and its frequency. And we're going to use that to make a word map, a word diagram where the size of the word, it's all real pretty. And again, making word maps is part of this d3.js visualization. Don't have to worry about that. Already downloaded it, and I've already written gword.htm. You don't have to change any of this. You can if you want, especially if you're sharp in JavaScript, and you can make your own visualizations. And then that basically loads and reads this stuff, and then that takes the data from gword.js and produces like a nice word cloud for you and looks real pretty. So that's the word cloud. Now, same thing, we can create a line and keep track of, this is going to be basically by organizations, and there's this program that reads Gline, it reads all the data, and it produces some JSON in the gline.js, and then here is a visualization web page that reads gline.js and uses the D3 to do visualization. So you don't have to write any of this stuff. You don't actually have to write any of this stuff, but it produces nice lines for you. And again, the whole goal here, most of the code is pretty much just sitting here. And the more interesting question is looking at it and understanding how a program that's doing gathering works, how a program that does cleanup works, how a data model should look how you represent clean data in a data model, and then how you write a series of analysis programs, and then just one of many techniques to do visualization. I just happen to use this d3.js because it's widely used by a lot of folks, and it also just works in a browser, so you didn't have to install any more software. So now we see our most complicated multi-step process, and then we'll take a look at how these things each run. Like I said, this is the Gmane page. They're trying to tell you just be nice, and to make sure to use the URL. I'll make it so it has the same API as the Gmane, and it'll make a nice local copy so we won't crush the Gmane server. Even if 100,000 of you want to download all the gigabytes, I'll come up with a way to make it so that can happen. So in summary, what we've seen is 3 different examples of a multi-step process to do simple data mining. Again, I emphasize this is not the sum total of everything that is data mining. Everything that's data mining is far more complex than this. This is kind of a multi-step process where we're doing all Python. And my goal for this is just to have you look at a series of more complex programs. And so I'll make sure in other videos to run through all these programs so you can see all the techniques that each program does to accomplish what it needs to accomplish.